Hi there, and welcome to the Gods Showcase series, where we will explore the tool Gods Globally Observable Data Structures to decouple and improve our Unity projects. We will further dive in to see how we can subscribe to events on our smart data structures, to easily react to changes in our stored values. Additionally, we will explore how we can use a simple yet powerful save slot system to save and load data while keeping our scenes synchronized after loading a save file. In this first episode, you'll learn how to use observable variables to decouple your game objects, making your Unity projects more modular and efficient. In a usual Unity project, we often need to reference other objects or components to grab some data or to react to changes in data. Here is an example. We have a movement input component which reads in the player's input. The player character has a movement component which makes use of the input component to make the player move. A camera script follows the player and also references the input component to rotate around the player character. Additionally, our player has a health component and we want to display the health of the player in our UI. The UI component then needs some sort of link to the player health to display the correct value. Maybe when the player takes damage, we want to give the player some feedback, so we play an animation, shake the camera, flash the screen, and play a sound effect. We can see that even for a simple example like this, the references we need can quickly become tangled and difficult to manage. Everything depends on each other, and removing parts of the scene can cause unknown issues and frustration. With Gods, we have a powerful tool to break these chains easily by introducing globally accessible data structures which can be referenced throughout our project. So instead of linking our objects, we only reference the values we actually need. What makes Gods very convenient is that its data structures host events we can subscribe to, enabling us to seamlessly react to data changes as needed. This enhances the modularity of our components, making code reuse simpler and improving overall code quality. Additionally, adding new features becomes much easier without the risk of breaking existing systems. But enough theory for now, let's dive into our first example in which we will break the links between our player input, player movement, and our camera script by introducing observable variables. For the sake of this video, I have already prepared a simple scene in which we have a player object, a player input object, and a camera, which follows the player. Before we have a look at the code, let's start the scene. In the current state, the player can jump and move left and right. When the player moves, the camera tries to move ahead of the player object so the user can see the space ahead of them. Let's have a look at the code in its current state, and then we'll try to improve on it. First, we have our player movement input class. This class reads the horizontal input and stores it in a vector2 field for other classes to use. Next, we have the actual movement class. This holds a reference to the input class and uses the stored value to make the player move left and right. We have another class which allows the player to jump. It uses a rigid body, and when the player presses the space key, it launches the player into the air. It uses a Boolean value as grounded, to only allow the player to jump if the player is touching an object which is tagged as ground. Finally, we have a camera follow class which is attached to our camera in the scene. It has some variables to control the speed and the offset of the camera. The script also references the player transform, the player input component, and the player movement component to calculate where it should position itself. If you are interested, here is how the code works. The script calculates the X offset, which depends on if the player moves left or right. It then stores the calculated value in a vector3 called target position. And then the camera moves towards the target position. Well, all of this does work fine, but if we look closely, there are some issues which could be improved, and by using our globally observable data structures, we can fix these issues quickly and easily. As we can see in the inspector of our objects, the scripts have references to other objects or other components in the scene. If I now remove the player, these references on the main camera are gone, and the camera script is broken and won't work anymore. When I undo the deletion of the player, the references on the main camera come back, but if I delete the player, then open another scene and come back to this scene, the references will definitely be lost. For a simple scene like this might not be a big issue, but when your project grows, this can lead to a lot of headaches. Also, why should we reference a whole component in multiple places when all we need is just a single value of that component? And here is where Gods comes into place by providing smart variables which can be accessed from anywhere in the project. So let's start fixing the scene by decoupling these scripts. First, we open the player movement input class and let's replace the vector2 field with a vector2 reference, and then adjust the code here a little. Next, in the player movement class, we replace the reference to the input class with a vector2 reference. This reference will later hold the same value as the reference in the input class. And since our camera class depends on the move speed of this class, let's replace the float variable with a float reference. Now let's adapt the code by writing movement input value.x and move speed.value, and that's it for this class. Finally, let's adjust the camera code as well. Instead of referencing our components, we want to reference the same observable variables as the other classes. So, let's replace player movement input with vector2 reference and player movement with float reference. Now we need to adjust the code a little bit. Instead of input vector, we write value, and instead of move speed, we write value as well. Do it down here as well. Okay, let's compile and we should see no errors. When we select our objects now, we can see that they are missing some references. So let's create the scriptable objects which will hold our values. Select the player input object and click the button called Create Variable in the inspector to create and automatically assign it to this field. We can see the newly created variable appeared in the inspector. Let's have a short look at it. At the time of the making of this video, each variable has a set of fields. First, we have a tags field, which you can use to mark this variable for filtering and searching purposes. Once your project grows big, this can be very useful. You can also add your own custom tags. Next, we have a reset data tags field. With this, you can control when the stored data gets reset. By default, the data gets reset when the game starts or when we enter play mode, but there are also other options like when you switch between scenes. Here you can also add custom tags to reset data of variables when a level is completed, for example. There are some more fields in the inspector, but let's focus on the stored values. We have a default value and a current value. The current value is being used at runtime. Once the data of variables gets reset, the current value gets set back to the default value. Since we have already referenced this variable on the player input game object, we should already see the current value changing when we enter play mode and press left and right. Perfect, the input value now gets stored in this variable, which is globally accessible. Let's select the player object and drag the same variable into the input reference field. Then, we need to create a float variable for the move speed by clicking the Create Variable button. Nice, it got assigned, but the default value is 0, so let's increase the default speed value to 7. And with that, we should already be able to move our player. Nice! Let's reference these variables on our camera script as well. And now the camera moves with the player. Great. But there is one more thing we could improve upon. When we select the camera, we can see that we have a reference to the player object. We can replace that reference with an observable variable as well. Storing the player transform in a globally accessible variable makes sense, as many other objects like enemies, NPCs, collectibles, and other things might need to use this value too. So, let's open the camera follow script again and replace transform with transform reference. In the code below where we do the null check add.value, then below where we calculate the target position add.value as well. Okay, let's recompile and create a new variable using the button in the inspector again. Now here's something to keep in mind. The variable which will hold our transform got created, and we can assign our player object to this variable in the inspector. But since our player object lives in the scene and the observable variable lives in the project, dragging the transform in like so won't give us the results we want. For example, once we restart the scene or load another scene, the player transform we just dragged in will be destroyed and the reference will be lost. When we select the transform variable, we can even see that the default value is a type mismatch. However, we still can drag in prefabs from the project window just fine, and that could be useful for spawning a certain type of object. But that is a different use case. The best way to assign the player transform to this variable will be through code. So, let's open the player movement class and add a transform reference called player transform, like so. Create an onEnable method and type player transform value equals transform. Now after we recompile, everything should work as before, and we got rid of all those nasty references between our scene objects. Since we assign the player transform via script, let's select the transform variable and in the description text type in something like getSetFromPlayerMovement component, so in the future, we don't wonder why the default value is not set. Then enable the checkbox which reads, Disable Value Field on References. When we now select the player or the camera game object, we can see that the transform field has been locked. This can be useful when values are already finalized, and you don't want to accidentally change them in the future. Before we end this episode, there is one more feature I'd like to show you. Let's open the Gods Hub window by going to Tools, Gods Hub. This window lets you view and manage all your observables in one place. There are some very useful filter options on the left side. You can also drag and drop the displayed observables from the list directly into other components, making the filter options even more useful. On the right side, you can either see the inspector of a selected variable, or you can click on Usages at the top to find all usages of a selected variable. To do so, let's first add the current scene to our build settings. Then, in the Gods Hub window, click on Refresh Usages Everywhere, and you should see in which scenes and in which prefabs the selected observable asset is being used. That's it for this episode. In the next one, we will use observable variables to add a basic health system and some collectible currencies. And we will use the events within our smart data structures to react when the player takes damage or collects coins to keep the displayed amount in the UI up to date.